Hi everyone. In section 1.3, we looked at a gallery of basic graphs. Now in section 1.4, let's transform those graphs. And you're going to become a lot more powerful because you'll be able to graph a variety of transformed equations. Our first set of transformations will be translations or shifts. You see the details here in this box, but these shifts are best explained through examples. For example, let's take a look at the basic graph y equals the square root of x. That's from our gallery. That's that purple graph in the center here. We're going to consider various translations or shifts of that graph, and we're going to see the corresponding transformed equations. So let's start with the graph. This is Desmos. Let's start with the graph of y equals sqrt, the square root of x. We get that hook, starting at the endpoint at the origin and extending through quadrant 1. Now, how do you graph y equals the square root of x all plus 2? What happens if I attach a plus 2 to the end here? We move the graph up 2 units. That makes sense because for every x value in the domain, notice the domain is the same. For every x value in the domain, we're going to get a y coordinate that's 2 higher than the y coordinate we got on the original red graph. So for example, at x equals 2, the y coordinate on the blue graph is 2 units higher than the y coordinate on the red graph, and so forth. Well, how do we shift a graph down by 2 units? Y equals the square root of x all minus 2. We go from the red graph down to the green graph. From the red graph to the green graph. We shift the graph down by 2 units. So these are vertical shifts or translations. They're the fairly obvious ones. To shift a graph up, you add a positive number at the very end here. To shift a graph down, you subtract a number. I'm assuming that you have the form y equals some expression in x. But what about the horizontal shifts? These are confusing for a couple of reasons. What if I want to take this red graph and shift it to the right by 2 units? Y equals the square root of x. I want to shift right. Actually, I'm not going to put plus 2. I'm going to put minus 2. And notice I'm doing it inside the radical. I'm substituting or replacing the x here with the x minus 2 over here. So you see we go from the red graph to the purple graph. Now, in fact, these are just horizontal shifts of each other, although it may not look like it because we tend to look at things kind of perpendicularly. But actually, if you look at things horizontally, there's always a 2-unit gap between the graphs horizontally. Likewise, to shift a graph to the left, it's y equals the square root of x. Now, to shift left, you might think it's minus 2. No, it's x plus 2. And again, it's inside the radical. You're doing a substitution, a replacement. And we go from the red graph here to the black graph over here. We're shifting left. So notice that the horizontal translations are harder for a couple of key reasons. Horizontal translations or shifts are harder for 2 key reasons. S's. First of all, it involves a substitution. A horizontal translation involves a substitution. You're substituting or replacing the x with x minus 2 in this case, or x plus 2 in this case. Here you see the changes inside the radical. Second, 2 more S's. The signs surprise. Surprising signs. All these S's here. Because again, to shift right, you go from y equals root x to y equals root x minus 2, not x plus 2. the sign surprises you. Likewise, to shift left, you substitute the x with not x minus 2, but x plus 2. So these are two key reasons why horizontal translations are harder. They involve a substitution. You're substituting or replacing the x, and you have surprising signs. In general, horizontal transformations are harder if you have y as a function of x. Later on, we're going to see combining these various translations so we can shift horizontally and vertically. For example, we could do root x plus 2, y equals the square root of x plus 2, all plus 2. That takes the red graph and shifts it northwest, left and up. So that's how we do translations. Next, we're going to talk about issues of domain and range and graphs in general.